So here's a basic turn part. Not all your turn parts will have an ID, but we have an ID here. We're going to show you how that is done. And so the part is oriented. The back face of the part is at the world origin. The x-axis is extending along the rotational axis of the part. So if you look at the machining job, when you start out, you have these items already listed. You have your machine, your post, your part, your stock, and one setup one. So we're going to go to the program tab. We're going to start on the left and define these operations. We'll start with the lathe, where you can set your maximum RPMs that you don't want to extend past, and these are just other traveling limits parameters that you can use. Those are all optional. So then you can define your post. We've got a FANUC standard FANUC post defined. We have quite a few posts in here that you will probably have a machine that matches that. If you have a machine that's not listed here, then just drop us an email to support@MecSoft.com and we'll verify that we can generate a post for your machine. So we got the post defined. There's the post. And for the part, you see it's listed as none. So we're going to go up here to the program tab. We're going to pick select turn part. For this part, we have a revolved solid. So we're going to use the left side of this dialog. We're going to pick select solid surfaces. We're just going to pick our solid. And you'll see the green arrows are pointing outward. That's typical of a solid model that you may, if you have a model and if you may have errors in your surfaces, if they're not pointing outward, then you need to fix those in the CAD system, and there's tools to do that. So all of our arrows are pointing outward. That's good. We're going to go ahead and pick save. So you'll see if we look at the top view that the turn system created this profile of the part, and that profile is going to be used to define your turning operations. Okay, so let's rotate over to this direction here, which is a good view for seeing the turning operations. So we have the machine defined, the post defined, we have the part defined. Now we need to define the stock. So we're going to go up here, do a cylinder stock. It calculates your dimensions of your part, and we're just going to pick OK. And we're going to turn the stock on over here. So here, if you look at this orientation, you'll see that you have the stock. It doesn't have to start with being aligned in the back, but right now it is. So we're going to align it anyway. So it's aligned with the back and then extends out in the rotational direction. So next we have the machine, post, part, and stock defined, and you can turn your stock on and off. And also what I'm going to do is I'm going to go ahead and change the stock color just to make it a little bit more like the slides. So there's our stock defined. So now I mentioned that we have setup one already defined, and by default it's oriented with your world coordinate system. If you turn on the machine coordinate system on and off right now, you'll see that it's located back here at the world origin. If you turn your world origin off, you'll see here is your machine coordinate system by default. Okay, so we're gonna leave the world origin turned off. We're going to leave the machining coordinate system turned on. So now what we're going to do.
That's really the setup coordinate system. That's okay. Not the, yeah, that's really good. And we need, because that setup defines the coordinate system. So that's what the setup, so we really have to call that the setup coordinate system, not the machine coordinate system.
Okay, because we're going to move and actually create the machine coordinate system.
That's correct.
On the front face.
Yeah.
So right now we're actually at that step. So we're going to go through, we did the lathe, post, the part, we did the stock. Let's go ahead and align it. I mentioned that currently it's already aligned with the back face, but if it's not, if you have a stock that's defined longer than your part, you can use this dialog here to align it on your part. If you look at the dialog here, it moves from left to right. So we're going to align it on the left so it's flush on the back face of the part. And we're going to pick OK. Material, you can set a material. Right now, we're just going to leave that in the default aluminum for now. We'll pick OK there. And you can, if you want to see a texture of the stock on the part, you can use this option here, just turn it on and off, but we're going to leave it turned off. Now, we're at the work 0. We want to put that work 0, you want to do it based on your stock box, especially if your stock extends out further than the part. So you want to use the set to stock box option, and we're going to do it on the right side of the stock model. So your work 0 is going to be on the frontmost location at the center of your stock model. So that's how you want to have it oriented for turning. So when you pick generate, it moves it up to the front face of the part. So now we got the machine coordinate system work 0 positioned for turning on the front face of your stock model. So now let's go ahead and do some turning. As I mentioned, we have some ID holes. So we're going to drill some of those holes out. Let's go ahead and turn and hide your actual part model. Okay, so we're going to work with the cross section of the stock or of the part for defining the drilling operations. So let's go up to turning, and we're going to go, actually from turning, we're going to do holes. We're going to do drilling. So we got a couple of drills here already defined. Let's look at the tool definition dialog. So here, basically it's the same as in milling where you define your drilling tool. We have it already defined based on the diameters that we have on our part, where the tool drilling diameter and the flute length, etc., is set so they can make these cuts in the ID of the part. So let's exit out of there. We got 2 drills defined. Exit out of there. So for the first operation, we're going to use the smaller drill, and feeds and speeds, set these to whatever you are comfortable with. We don't recommend any specific feed and speed. So whatever feeds you see on this dialog, we're not recommending those. These are just default values. And for any feeds and speeds, you need to go by your experience and your machine on how you are familiar with how your machine runs optimally. So here you can define your feeds and speeds. You can define them when you define the part, or you can define them here when you define the operation. And then also the clearance plane, you can define that based on, now we're doing drilling, so our clearance plane is on the front face of the part. Now for cut parameters for drilling, we're going to go ahead and do a break chip drill, which means that the tool will chip in and out at a certain increment. And our step increment here is 0.1. Let's increase that a little bit to 0.25. And for the location of the cut geometry, it's at the top, meaning the front face of the part. This is the top. If you're looking at a milling, that would be top. So it's the same nomenclature here as in milling. So for our depth, we don't know exactly what that depth is, so we're going to use the pick button, and we're just going to pick 2 points. We got our end snap selected. We're going to use from this point to the back point. So we want to go all the way through with this drilling operation. And when you do that, you need to make sure you have some extra stock in the back of your part, because the drill will extend out the back the way we're going to do it. We're going to add the tool tip, and that's going to make it extend out the back. And let's go ahead and generate this. So we see if you go into the preferences and you increase the width of your tool path, you'll see it a little bit better here. So here's our drilling and our peck increments. Let's go ahead and simulate that. Slow that down. Let's turn this to a 3/4 inch view. Let's set the simulation to fine. And then I didn't quite take it, pick OK. So there's our stock model when we get started. And we're going to go ahead and simulate the brake chip drill. So you'll see that the tool, the full diameter of the tool went all the way back to this point that we picked. And because we picked extend the tool tip, the full diameter of the tool went to this point in the back and extended outward. If you want to look at that, we'll go to the front view and look at it, or the back view, actually. And we'll run that simulation again. Okay, so there's our first roughing operation. Let's go ahead and change this to top. Then we'll go to ISO and go back this way. Okay, so there's our first drilling operation. Now we got this area in here that we need to rough out. So we're going to use another drilling operation for that. We'll go to Program tab, Holes, Drill. And for this, we're going to use our larger drill diameter that we have defined using the tool dialog. This diameter is what we want to rough this larger diameter out. So for the feeds and speeds, again, set those to what you're familiar with on your machine. Set the clearance. Now for the cut parameters, again, we're going to do a brake chip. We don't know the depth yet, so we're going to use the pick tool. We're going to pick from here to here. So it has to go in at least 1.457 inches. We're going to go ahead and add the tool tip. So what that's going to do, the tool is going to come down to this position, and then it's going to cut some of this material off, which is okay for this particular application. So let's go ahead and generate that. So here's our second drilling tool path, and we'll go ahead and simulate that. So there's our roughing for the ID. If you turn the part on, you'll see that we got pretty much all the material out on both faces here on the inner side, and that we're make sure that you're acceptable with this angle here from the tool as we went past the point for depth. So there's our roughing. Now what we can go ahead and we can do some outer roughing. We actually, what we did on these inner holes, we actually roughed and finished it. So we did the exact diameter for the inner holes. So we don't need to do any more finishing on the inner diameter. So what we're going to do is we're going to go turn, and we're going to go roughing. And we have a roughing insert defined. Let's see what that looks like. So for inserts, you have 5 types of inserts. You've got diamond insert. Typically, you're going to be using a diamond insert most of the time, I would imagine, but you do have triangular inserts, round, polygonal or trigonal, and then straight inserts. So we're just going to use a diamond insert. So for the dimensions here, set these to the specs of the insert that you're actually going to have installed on your tool insert carrier that you're going to be mounting that in, your tool holder. So we've got a circle radius of 5.5. We've got a tip radius, a tip angle, and a thickness and a relief angle. Now here is where I mentioned where you can set the OD forward or OD backward of the tool. With the OD forward, we're not going to be able to, and when we get to the actual production, you won't be able to cut in the back. So we're going to show you that. But on this particular part, we don't have any undercuts in the back. So we're just going to leave it at OD forward, and we're going to exit out of there. And again, feeds and speeds for finishing, or I mean for roughing. We got our global parameters. We got a tolerance that we have set for roughing. This doesn't necessarily have to be really tight. It defaults to 001. We'll just leave it there. We're going to leave 10 thousandths of stock on the outside. Again, if I'm going too fast, ask questions so that we can get them answered. And if I'm going too fast, let me know and I can slow down a little bit. So we've got turn roughing. We're doing an outer diameter. You can select that to front facing or outer diameter. If it's set to front facing, it'll do your front face of the part. If it's set to outer diameter, it will do the outer face of the part. So let's go ahead and do the outer face, the outer diameter of the part. So we got it set to outer diameter. If you want to control where you rough the part, by default, if you leave it at 0 and don't use any containment, it'll go the full definition of the part. So what we're going to do is we're going to define a containment area. So we're just going to do it from here to here. Okay, and then we're going to go to our turn roughing tab. You can set the cut pattern. You can do an offset pattern or a linear pattern. We'll leave it set to linear. You can set your cut pattern, which is positive or negative or zigzag. Basically, similar in milling terms would be, climb, conventional, or mix. In this case, we're leaving it in the positive direction. And we'll turn off the cleanup pass. And this will use the top of the stock model to determine the top of the cut, and we'll do a cut depth of 0.625. Entry and exit, we'll leave those to the default values here. If you look at the dialog, this is how your entry engage and entry motion, and then your departure and retract motion. You can set those for the entry as well as the exit. Clearance, again, this defines a clearance cylinder that the tool will retract to when it's traveling to get to another area. And for advanced cut parameters, you also have arc fitting that you can perform. We don't have any arcs on this part, on this profile, so we don't need that. So let's generate this. So you'll see that it looks like our stock was the same size of our part, so we didn't go back in that area. So let's take a look at the stock a second. Yeah, so we defined our stock the exact size of the part. If we defined that in a larger diameter, let's say a tool radius of 0.3, pick OK. So that adds more stock to the outer side. Let's go ahead and run this again. And let's go ahead. It looks like it didn't get that. Let's go back in here a second and let's go to global. Let's see if we can do that a little bit differently here. Let's go from here and let's say out to here and pick generate. Okay, so that allowed it to get to the extreme outer diameter in the back. That's a good tip right there that I just showed you. When you define, if you're going to contain it, make sure the containment rectangle encompasses the maximum dimensions of your stock. So when I picked that, I picked 2 points from here and I went way out here to this quadrant. As long as it's out larger than the stock diameter, it's going to take the full stock diameter into account. So let's go ahead and simulate that. And let's go ahead and load this up just a little bit. And let's hit the play. That's a little bit fast. Let's also change some colors for that operation. Let's cancel out of that. Let's go in here and change some properties and change some colors to roughing. And then for simulation, we'll set this to mop. This inherits the color of the operation property. So let's go ahead and simulate that again. And also let's change the colors of the inside holes so you can see those a little bit better. Let's do this one. Okay, and let's go ahead and simulate all of that. So here is our outer diameter roughed out. So we've got the inside finished out. We got the outside roughed out. Now what we're going to do is we're going to come back with a finishing operation. We'll go to the Program tab. We'll go to Turning, and we'll go to Finishing. And we're going to use the same insert that we use for roughing. And now you may have noticed this when we did the roughing, there was an option to do a cleanup pass, and it will clean that up. And if you have your stock set to 0, then in effect what you're doing, if you think about milling, if you have a stock of 0, the tool matches the actual part surface. So you could have done a roughing and a finishing in the roughing operation itself just by adding the cleanup pass. But we're going to go ahead and do a second operation with probably a new insert, and we're going to do a finishing operation. So feeds and speeds, set those. For the global parameters, we're going to go ahead and do a finishing. We're going to select the dimensions again. We're going to do from here up to here. And let's see what else we got for finishing parameters. You can do that in multiple passes. We don't need that because we only left 10,000ths of material on here. But if you had more, you could do multiple step downs. Again, entry and exit is the same as in roughing. Again, your clearance plane. This is the cylinder where your insert is going to retract to when it it's going to retract to, and it's going to disengage in this direction at that cylinder. So for the advanced cut parameters, again, we don't have any arc, so let's generate that. Let's turn the toolpath on. So you'll see that we have, let's go to the top view. You'll see that we have the finishing starting here. If you wanted to, you could have it start here, and it would actually finish this whole face and all the way back, and then it stops back here. And here, this is our exit motion. You can control this magenta motion. You can control the green motion, and of course, you have your retract. And the same on the entry. You can control the approach and the engage and your plunge. So let's go ahead and do a simulation of that. Let's go back into this orientation and let's do a simulation. Slow this way down. Let's go ahead and check the color for this. We want to set that color to our finishing color, and let's play that. So here is the finishing. It finishes this chamfer, finishes the outside diameter. Again, the OD forward of the tool was such that it didn't have any problem getting this angle cut. So we got that finished. We got the larger diameter finished. And then we got a little bit of material left on the back. It looks like that's going to just fall off. So we don't need to worry about that. So it looks like that is pretty much all set. If there's any questions, go ahead and add them. We got about 20 minutes. Looks like we're running okay on time. So let's go ahead, and we did the simulation. Let's just go ahead and post this out. We'll select setup 1. We'll right click and post. And we'll just post that out. And here is the G-code for the FANUC controller. We got our brake chip drill. Let's do a search on the letter T so we can find that easily. Letter T. So there's our first tool. There's our second. These are both drilling operations, and then we're going to do our next. This is the turn roughing. And then we're going to do our turn finishing. And then here's another finishing, and that's the end of the tool GCode file. So there's our code for this particular part. Now, let's take a look at that complex part. Now, this is what we saw in the slides, okay? So we got our part. Let's turn the stock off, and let's just look at the part definition. Let's turn that off. Again, when you define your part, you don't have to leave your part geometry turned on. You can turn that off. So we show our stock. So this is our profile that we're cutting, okay? And we've got our work 0 set to the front face of the part. We have our part aligned to the back edge of the part, as you can see there. Let's go ahead and turn that off. And again, we're doing drilling operations to clear out this material. So let's look at the brake chip. And actually, let's go in and look at the tools first. Let's see what we have set up for tools. Okay, we've got a diamond insert, OD forward. So this is going to do all of the roughing and the finishing up to this point. We cannot do this back radius and angle and backside. We cannot do that area with an OD forward tool because it'll just go to this point and it'll just slide right down because it won't gouge the part. So we've got a diamond insert, OD forward, and we have a diamond insert, OD backward. So with the OD backward is we can use and get into this back area, and I'll show you that in just a moment. So we also have some more inserts oriented for the ID on the inside, and for I guess this is for the front face here. So let's look at, when you do turning operations, you have all of these toolpaths you can use. So here we've got the inserts, a diamond insert, a triangular, a circular, a trigonal. This is a parallelogram. Then you have a groove insert, a thread, and you have a parting off insert. Here we got our drills defined. We have 3 drills defined. Let's go ahead and exit out of there. And let's go ahead and look at our first brake chip operation. We have our drill 29 defined, and we've got feeds and speeds and clearance defined for cut parameters. We've got a cut depth of 71, which goes all the way through the part. We have the tooltip being added, and we're doing a brake chip drill at a step increment. That looks a little bit kind of high. Set that to 1/4 of an inch. And we've got our cut depth, like I said. Let's just generate that, and let's simulate that. Slow that down. Slow that down. Turn our stock on. Okay, our stock's on, so let's take a look at that. So here, you notice that it didn't go all the way through the back, and I did that on purpose because I'm going to show you a parting off operation that'll clean that up. So here's our first drilling. And then we done another brake chip drill. Let's just go ahead and play that. So what you'll see, let's go ahead and change the color of this just so it's consistent. Okay. So what you see here after the second drill, that we have it roughed out with this diameter for the larger drill and this diameter for the smaller drill. So we calculated these drilling tools so that we don't have to do any ID roughing. We're doing all the roughing with the drilling operation. So we're going to come in here in this next operation, and we're going to do roughing and finishing on this little lip right here. So let's go ahead and play that. There's the roughing. and let's go ahead and do the finishing. Okay, so now you'll see that we've got finished and roughed on the inside. We got our groove finished. Now our next operation is an ID finishing operation. Let's take a look at that. So we got our diamond ID forward tool, and you'll notice that we changed the angle of this tool, the relief angle, and I'll show you that in a moment, in order to get this cut properly. So we got our feeds and speed set, we have our global parameters, we have a tolerance, we need to tighten that up, and we have a stock of 0 because it's finishing. We have a containment area set from this point to this point. That's the area that we need to finish. Finishing parameters, we're going to do multiple passes, and we're going to do a depth of cut, and we're going to do a total cut depth. And we got our entry and exit, the clearance, advanced cut parameters. We got arc, so we got arc fitting enabled. Let's go ahead and simulate that. Let's zoom in a little bit. So what you see here, let me pause that a second, is I changed the relief angle of this insert. Typically it would be leaning forward like this, but I rotated this upward so that we can get this finished out without leaving material here. If the orientation of your insert is such that you can't get at anything, it will not cut it. It will not gouge the part. So let's go ahead and finish this. So we're doing multiple passes. So there's our ID finishing operation. Let's see what we're doing now. So this is our OD roughing operation. Now, if you see here, you see that it didn't get in this area, and that's because the orientation of the tool is OD forward, outer diameter forward. If we look at the actual tool, you'll see that it's an OD forward tool. Let's exit out of there. Let's go ahead and cancel that and run the simulation. Speed that up just a little bit. So you'll see when it gets down to the groove, let's see if it gets any, no, it just skipped the groove. So now we're going on the back. It will not gouge the part, so the tool is just riding down that edge and getting as much material out as it could. So it did come back and get the groove. Okay. Let's wait for that to get done. So in this particular roughing, we had a finishing pass set. So you'll notice it came back and did a finishing pass, leaving our stock material there. It could not get in all of the groove. That's fine. It leaves our stock material all around, and it will not cut that material out because of the orientation of the tool. That's why we need a second operation with the tool set to OD backward. It's oriented in the backward position. Let's go ahead and simulate that, slow that down. Let's go in here. So the tool is on an OD backward orientation, and it's cutting this back area of the part. These are both roughing operations. So now let's look at, we also have some finishing that we need to do. If you noticed on the roughing, we still have some material here. You could go in and do a roughing first. I don't have a roughing, don't look like I have a roughing in there. I did it all with the finishing. But you could go ahead and do a roughing operation to relieve most of this material and leave some stock. We just did it with the finishing, so let's go ahead and just play that. So we did our finishing operation starting at this top position here at this point, and it finished the chamfer and all the way down to the center. We could have just went to here, but we just had to do a clean break off of that diameter right there. So let's look at what else we got. We got a groove finishing. No, we got an OD forward operation and finishing. Similar to the roughing, you need to have two operations for finishing because the orientation of the tool is such that it can't get this back area. So let's look at the finishing dialog here. We've got an OD forward insert. We've got our feeds and speeds, our global parameters. We have the cut containment set from this point here to this point here, and you'll see that it won't get in this back area. So let's go ahead and look at what we got else. We got, let's do some arc fitting too. Let's double check our tolerance here. We got finishing parameters. We don't need any cut downs. We're just going to do one pass, entry and exit. These are all pretty typical for roughing and finishing on the turning operations, clearance, etc. And let's go ahead and generate that. And let's simulate that. So it's doing a finishing operation. And you'll see it just skipped that back area. Okay. So we need to go back in there with another operation. And it finished only half of the groove. So the finishing operation is exactly the same, but it's just got a different insert oriented in the OD backward position. And let's go ahead and simulate that. You'll see here that for the containment, let's go over here to finishing parameters, global parameters. You have cut containment. We selected from here, this endpoint to this endpoint. So it's going to clean up this area again, just go over it again, and then it's going to do this back side. Let's go ahead and simulate that. So here is the finishing operation on the back side. So now we still got some groove roughing and finishing to do. So let's go ahead and look at that. We got about 5 minutes left. Joe, we got any questions?
Not too many.
Okay.
So you can keep going.
Okay, so we've got a groove roughing operation. Let's take a look at the groove insert. We got it defined. The width of it is three. This part is in millimeters, by the way. The part that we did first was in inches. So we got an insert that's 3 millimeters wide, 3 millimeters thick. The total width is 12 millimeters. And we're going to go ahead and rough this out. And let's go ahead and take a look at the roughing operations, the roughing parameters. We have our cut containment set to the width of the groove. And we're doing an outer diameter. This means the groove is on the outer side of the part. And we got our roughing direction, our unidirection roughing. That means, how is it going to move when it gets into that groove? And we have a step distance, a step down, and we got our entry and exit. We've got advanced cut parameters. We don't have any arcs in here, so we don't need any arc fitting. Let's go ahead and simulate that. So it's left some stock material here and over here. So we're going to do that with our finishing operation. So there is our groove finished. Now, obviously, the corners have fillets because of your insert will probably have a small fillet on it. You may be able to get one with a sharp corner, but it does have a fillet because it inherits the radius of the insert. So here is where I mentioned if you have material left over let's say it didn't cut all the way back, or let's say that the center drill didn't go all the way back, you can do a part off operation on the back side. So let's take a look at that. So here we got a part off tool, which is just a straight rectangular tool. We have a length and we have a width and a thickness. Okay, and it's going. You can tell it which edge of the tool to cut with by setting the left, right, or center. We're going to leave it set to the left side. And feeds and speeds, again, you know about that. Parting off parameters. Our radius is 0. This means it's going to go right to our origin. If you want to leave a small amount, you can set this to a positive value. And this is the location from your machine coordinate system to the part off location. So we have it set to 770.052. You can actually go in and pick that point as well. If you had left extra material on the back, you can actually change your cutoff position. Let's select near. And let's say that we don't want to cut off here. We want to cut off, say, right here. It should take that position. Let's see how that works. Let's generate that. Let's simulate that. Yep. So what it did, it took this slice of the back part of the part off. Again, you don't have to take it off. You can leave it set to the back corner and it'll just clean that face off. So let's do a simulation of all the parts. Let's speed that up just a little and we'll select the setup and we'll just hit play. Our drilling, ID finishing, OD roughing, part 1. And then we got OD roughing, or that's our cleanup pass on the roughing. And then we got our roughing on the back side. And now we're doing our finishing, and then finishing on the back side, and then the groove, and then the part off. So this is how you, oh, and one thing I'll mention before we quit, this part file is available if you want the fully programmed part. Just send us an email at support@mecsoft.com and we'll send you both the part files shown in this webinar. Any questions, Joe? We look like we made it right to the end.
Yeah, no, that's, I think we've done pretty good, done a pretty good job right at 9 o'clock. So thank you all for attending, and then we'll see you next month.
Take care.
On our next webinar. Yeah, take care. Bye-bye.
Bye-bye.